Good evening, everyone. This is the second session to learn arrays in C language. We've already seen the basic concepts of arrays in our previous session. So before we begin, let me ask you one question that the recorded videos that I had sent regarding functions and pointers, how many of you have watched them completely? Pratik, have you seen them?
No, I was busy little bit, so not completed yet.
Okay, okay. Ruchi, have you seen?
No, I did not.
Okay, so see them as soon as possible because now other students have also joined this course, no? So we both have to come at the same level so that I can conduct the combined lectures. And before we begin, so others also who have not seen, you can see them as soon as possible. And before we begin, I want to show you something that I've prepared. See here, this is a Excel sheet or a spreadsheet in which in which I've included the links that you must refer. Okay, so first is how you can install Dev C++, which I've already done. Then how to use an online compiler, means the link to the compiler. And if you have any doubts, suggestions, feedback, or comments, you have to click on this Google form link. Okay, so let me open this form and show you. All the links in this sheet are clickable. So you have to enter your email ID, name, class, division, roll number. Then according to the options, select whether you want to ask a doubt or suggestion or whatever. You can type your doubts here, and if you want to explain something or communicate something using any screenshot or documents, that also you can upload. Okay, so any doubt if you have, you can ask through this Google form so that all your doubts are in one place and I can answer them whenever I have time. Then next link is for the syllabus of this course. Okay, and then there is one introductory PPT also, means for the first session, actually for the new students I've conducted today this morning. So for them, so that they will see the recorded videos. In that, each topic is mentioned, how many lectures I've conducted for each topic, the link to the lecture. Okay, if suppose I click, and for you people who are old students who have already enrolled in in this course, you can access only the videos which I've sent on the group. They are the recorded videos for you. The live classes which I had taken for you, you cannot access their videos. Only they can access. So for example, functions videos are recorded ones which I've sent. So if you click on the link of the function videos, and then it will load, the page will load, and you can access the video by playing it, fast forward, rewind, and whatever. Then the study material, like the PPTs and notes that I've prepared. If you click on whichever, you can open that. All I've uploaded on the drive and the links I've provided. So you will not lose any notes here, okay? All the notes are here for each topic. Then the assignments also. Now some of you have submitted, some have not submitted. So some of you have the link, you have deleted the chats, or you may not have. So each assignment link and the submission link. Okay, some assignments are MCQ, so the assignment link and submission link is the same. But some assignments you have to upload the programs. So which programs you have to upload? Suppose I choose this one. So when I click on that link, whatever was the assignment that will get displayed, and the corresponding link at the side of it, if I click, I can get the submission link. Okay, and for the MCQ ones, the assignment link and submission link is same. But for the others, you have two links. One is to see the assignment, one is to submit the assignment. And though the deadline has passed, okay, so if you submit after the deadline, your marks will be reduced, but still you can submit. So the new deadline for each assignment with respect to the new students, even you can submit it now, there is no problem. So before the deadline, before 11:59 on that day, that is on 16th of May, before 11:59 you must submit. and I'll keep uploading the assignments here only. And as soon as I upload, I will send you the notification so that you can check this sheet and you can access whatever I have uploaded. So constantly you have to keep a watch on whatever I'm uploading on this sheet. Have you understood?
Yes.
Okay. Now we'll just revise what we had seen last time. Classification of data types we have seen, they are primitive and non-primitive. In non-primitive, you can have linear and non-linear. Okay. Linear means one after the other you can store the elements. In non-linear, you may have a number of elements which may not be in a linear fashion. Means in arrays that we have already seen, one after the other you can store the elements like A, B, C, and so on. But in non-linear, like a tree diagram or a hierarchy, you can have the elements arranged. You have already seen this. So array, so I repeat that array is a linear data structure in which finite elements, okay, you can't store infinite elements in an array, finite elements in successive or consecutive memory locations. Means memory locations one after the other. I've shown you what are consecutive memory locations already in the previous session. And all the data that is stored must be of the same type. You cannot have a combination of data types. Like all the integer values only can be stored in a single array. All character values must only be there. You cannot have integer with character or character with float. And index starts from which one? Can you tell me? Which number?
0.
Yeah,
0.
0 to n. Yes, 0 to n minus 1. So if there are 5 elements in your array, index is from which number to which number?
0 to n minus 1.
Yeah, so n is 5, so 0 to 4. Okay. So 0 is lower bound and n minus 1 is higher bound. We have seen one-dimensional arrays. We'll see some more programs today and also two-dimensional arrays. Syntax, you must mention the data type, suppose integer, then the name of the array, and then size. Suppose you want to store 5 elements within square brackets, 5 must be written. This is declaration. If you want to initialize, you have to put assignment operator, that is single equal to, and within your curly braces, you must list out the elements. Okay. For example, these are the elements that we want to store. So index starts from 0 to n minus 1. But here there are But here, how many elements are there? There are 9 elements. Okay. So index will go from 0, 1, 2, 3, and so on up till 8. Okay. N minus 1. So the length of the array, if is asked in the question, then it is 9. That is number of elements that are stored. First index 0, last index 8. We have all seen this. I'm just quickly revising. See here, example, int ARR of 6. Okay. Means 6 elements we can store. So we have also seen the conditions when we are storing lesser elements and when we are storing greater number of elements. That also we'll revise now. So you can store 6 elements. These are the values that I've stored. And if you print the value of a of 0, then first element will be printed. If you print the value of a of 3, then third element will be printed. That is here, according to index value, it is fourth element. Okay. This is your first element, then second, third, and fourth. Okay. So, and consecutive address. Now integer will occupy 2 bytes. So starting address, if it is 100, the first element is stored at 100. Okay. Then the next element will be stored at plus 2 location. Means 100 plus 2 is 102. Next element will be stored at 102. Then after that, again you have to do plus 2. So 104 at that position, next element. Okay. And we have also seen how to calculate the address of a one-dimensional array. Suppose the element, find the location of the element 5. Okay. In our previous example, 5 is present at index 4. Okay. See, I'll show you. The element 5 is at index 4. So here the example is a little different. Okay, you can consider 3, 4, 6, 5, 1. Okay, if these are your elements, 3 is at index 0, 4 is at index 1. Okay, this is your value of I. I is the index over here. 3 is at 0, 4 is at 1, 6 is at 2, 5 is at 3, and 1 is at 4. Okay, 5 elements, index is up to 4. So base address is given in the question, that is 100. Okay, base address is 100 plus what is the index that we are interested in? We are interested in the index of element 5, that is 3, into size of element, means how much, since the data type of this integer is, since the data type of this array is integer, and here we are considering integer to occupy 2 bytes. Okay, so that is the element size. The size occupied by the data type of the array in memory is 2, so that is your element size. So 100 plus 6, multiplication is higher precedence than addition. So 3 2s are 6, 100 plus 6 is 106. Okay, similarly you can find it for any index value. We have seen this array declaration. If we say a of 3, this is declaration or initialization, can you tell me?
Both.
This is declaration, no, because I have not written equal to, and within curly brackets I have not written anything. So this is not
Yes.
initial. Yeah, this is not initialization, declaration. So what will be stored in memory at those locations? Garbage value. So that you can see here, any value you can obtain if you print this array. Okay, if you print this array, then any garbage value will get obtained. Second case is what? Initialization. So 1 to 3, 3 elements can be stored. Okay, because size mentioned here is 3. Similarly, if all the elements can be same also, 1 1 1, 2 2 2, anything you can write. Then next case, between difference between declaration and initialization, you can have empty initialization also, means just write the curly braces without specifying elements in it. So the default value stored in each memory location is 0. If in this curly brace you store any element, then the 0 will be removed, and whichever element you have stored, that will come in the memory location. Okay, we have already seen this. I'm storing a single element 0. Okay, this is the first element, and by default other elements are 0. See the next example. Here you have storing only one element, but you can store 3 elements, but you're storing one. Okay, so whichever element you store, since you're storing one element, it is the element at a of 0. And the remaining elements, that is a of 2 and a of 1. Okay, these two are by default 0. Only first element you have stored. Now suppose you have the array int a of 3 is equal to, and in my curly brackets I'm writing the numbers 4 comma 5. Okay, 4 comma 5, but I can store 3 elements. So can you tell me in memory which are the elements that are getting stored?
4 and 5.
And one more element will be there, no, because I can store
0.
3 elements. Yeah,
0
you can
garbage
store
value.
0. Yes. So what is the value of a of 1 over here? A of 1 is 5, no? See, this is what 2 elements you're storing. So from the beginning only you have to store. In between randomly they won't be arranged. Whichever is your first element in the curly bracket, that is a of 0. And whichever is the second element, that is a of 1. And whichever element is absent, all that is 0. Have you understood?
Yes.
Okay. And this is deprecated or invalid now. So I'm not going to explain the last case. Okay, so before starting with two-dimensional arrays, let us see some more programs based on one-dimensional arrays. So you can, this is what empty initialization. So what are the values which are stored in memory? Can you tell me for this one?
0, 0.
Yeah, very good. So whenever I access a of, so which are the valid index values? 0 and 1. Okay. So when I access a of 0, I'll get 0, a of 1, I'll get 0. What if I access a greater index, a of 3? And what if I access a lower index, a of 2? That we will see today. So when I run this program, see, first I'm printing a of 0, that is 0. A of 1 is also 0. But if you go above and if you go below, what you'll get? Garbage values. Okay. So whatever is the range of the array, only there 0 will be stored. Above or below, it is garbage value. Okay. Next case is array declaration by initialization. I can store how many elements here in this array? According to this size, how many elements I can store?
2.
Yes, but here I am initializing 1, 2, 3, 4, 5 elements. Okay. So, but this does not give you error. Okay. In C++, it can give you error, but in C language, it does not give error. So what happens? Index is starting from 0. And since I want to print all the 5 elements, okay, so 0, 1, 2, 3, 4. For these many iterations, my for loop will run. And for the index value 0, 1, 2, 3, 4. So let me run this program first. So first element 10 you're getting, second element 20. Okay, you can get only 2 elements in this case, and all the remaining places you may initialize, but those values you will not get. You will get again garbage values. Okay, have you understood?
Yes.
Yeah. So if you initialize greater number of elements, only according to the size, those many elements you can access. And if you initialize lesser number of elements, suppose I write 10 comma, if I write only 10, so what will be the elements stored in memory? Can you tell me?
10 and 0.
Yes, very good. 10 and 0. So these are the cases of declaration and initialization. Now we can see how we can find the sum of elements of an array. Okay. So suppose this is an array which can store or hold 5 elements, but I have initialized it to 4 elements and sum is equal to 0. So we have seen how to traverse the loop or access the elements of the loop using of the array using for loop. So whatever is the index values that are acceptable index goes from 0 to 4. So for those many iterations, your for loop should run. So 0, 1, 2, 3, 4. So I should be less than 5. That is, I should be less than size. Okay. And then you have to, what you have to do first, sum is equal to 0. Okay. Let me dry run it. Okay. When I show it for each iteration or for each step of execution, what is happening? That process is known as dry running your program. Okay. Dry run. Let me write it here. Dry run. So for I equal to 0, what will happen? Sum is equal to sum plus a of 0. Okay, because I is equal to 0. So a of 0. But what is a of 0? Can you tell me?
5.
5.
Yes, 5. Yeah. So sum is equal to sum plus 5. That is sum is equal to 0 plus 5. That is 5. Okay. And when I becomes incremented by 1, then sum is equal to previous sum. Okay, means in the same variable we are storing, plus it will be the next element of the array, because I has become 1. Now sum plus equal to a of 1, that is 2. So it will become previous sum is 5 plus new element that I'm adding 2. So it is 7. Okay. This way you can traverse for the whole array. So in this case, I'm calculating the sum of the array elements. In another case, what I can do, I can calculate the product of the elements of an array. Okay. So similarly, you can have different operations. If you want, you can calculate difference also between them. But difference is not commutative, so be careful. So sum of array elements is 11. So let us cross check. 5 plus 2, 7, 8, 9, 10, and 1, 11. Okay, we are getting the sum. So we have seen how to calculate sum. You can do it for product. What change you have to make in the for loop to calculate product? Can you tell me?
In place of plus, there should be star.
Yes, very correct. Now, how we can accept the elements of an array from the user. Okay, this is important. Till now, we have directly been initializing the array elements. Okay, just a minute. So how we can accept from the user now. So suppose this is what empty initialization. Now by default, if I go to print this array, which elements will I get? Can you tell me? I'm not accepting from user. I'm directly printing it. Then what elements I'll get?
0, 4 times.
Yeah, how many? Yeah, very good. 0 4 times. But instead of doing that, I'm accepting from the user. So there's one more way to calculate. You can accept it, and before that, there's one more way to calculate the size of an array. See, now array is a derived data type. Means it is not your basic integer, float, or character. Means what? It is a derived from the primitive data type or basic data type. It is derived from the integer data type, or it is derived from float data type, or it is derived from character data type. So whenever you calculate the size of an array, okay, till now size of variables we know. If it is integer variable, it will occupy 4 bytes. If it is float, 4 bytes. If it is character variable, it will occupy 1 byte. But what will be the size occupied by array? So size occupied by array is equal to number of elements. Suppose n are the number of elements into the data type size. Okay, for example, here the size of array is 4. So if I substitute n equal to 4 in this formula, 4 into, what is the data type of this array? Can you tell me?
Array.
No, data type is integer. You can store
2
integer
bytes.
variables in the array. Yeah. Yes, 2 bytes it will occupy integer. So data type ka size is 2. Okay, array is not a data type. It is a data structure. And this data structure is derived from the basic data type. Okay. This all things I've explained in my previous lecture. So 4 2s are 8. Okay, so size is 8. So let me and array, if it is occupying in my compiler, it occupies 4 bytes. Okay, so 4 4s are 16. So if I just execute to print size, okay, before this, let me print using %d. Size is integer, okay, so we have to use %d or %i, and then I will print size. I'll just remove all this, I'll comment it out. So here I'm just printing the size of the array. Let me remove this part also. So see here, you're getting 4 into 4, 16. Okay. Now, in order to calculate the length of the array, okay, size means, till now we were saying size means length, but actually size means it is how much we are occupying in memory. So in memory, we are occupying 16 bytes. Okay, let me write it here. In memory, 16 bytes. But to calculate the length of the array, that is number of elements of the array, using the size, okay, that is called as length of array using size. Okay, we know the size, and using the size we can also calculate the number of elements that can be stored. Okay, so the formula for this is size of a divided by, that means you'll get the quotient, okay, divided by size of a single element of an array. Okay, here single element means you can either take a of 0, or you can take a of 1, or you can take a of 2, or whichever, but within the range. Okay, index values are from 0 to 3. So a of 0 you can take, or a of 1, or a of 2, or a of 3. Any one you have to take in the denominator part. So what happens? Size of a is 16. Okay, let me replace the value 16. And size of a of 0 is how much? Can you tell me?
4.
Yes, very good. 4. So 16 by 4 is 4. And that is the length of our array, isn't it? We can store 4 elements, so length of our array is 4. So you take the total size, divide it by size of any one element. You will get the length of the array. So this is how you can find the length. So now let me print size and show you what will happen. It is 4. Okay. Now getting back to the program. So the user has to enter 4 elements. Now user can give, or in the program you can write scanf 4 times. But what is an efficient way? Put it in a loop. So acceptable index values 0 to less than size. Less than size means I value will go to size minus 1. So scanf %d, and where you have to store the values that the user enters in a of I. Within a of I, you have to store whatever the user enters. So a of I each time will become a of 0, a of 1, a of 2. And ampersand means at that location you're storing the elements. You know how scanf works, okay? So here, instead of writing the variable, you must write the element of an array for each index. Then how to print what the user has entered? You have to print the array. So 0 to less than size, print a of I, okay? Have you understood this program?
Yes.
Yeah, now we'll run it and see what output we are getting. So user is getting the message that enter the 4 elements. So 2, you can either give space and then enter the next element, or you can keep pressing enter. Okay, so user has entered these elements. Okay, same what we have entered, we are getting. Now, if I reduce the size, okay, here I'm telling size, but here if I say 3, okay, so size is actually here, what is the value of size? It is 4. So size is equal to 4. But here I'm doing less than 3. So acceptable values of index are 0, 1, and 2. So in this case, I can accept only 3 elements of the array, but I can store 4 elements. So let's see what happens. So enter 4 elements, but I mean 3 elements, because I've not changed the message here. So I can enter 3 elements. Okay, and by default, I've told you that if you miss any element, it is 0. Okay, have you understood?
Yes.
Yes.
Yeah. Now let us see if size is more than 4, like suppose 5. So acceptable values are 0, 1, 2, 3, 4. But I can store only 4 elements. So when I run this, I can accept 5 elements. So see, you're getting some garbage values afterwards. Okay, so this is what happens even when you're accepting from the user. Now next program that we can understand is deletion of an element from an array. Now see here, if you want to delete an element, it is not that you can delete any element randomly so that that place will get filled with 0. Okay, whenever you delete an element, whatever elements are after that element should be shifted forward. For example, if you have the elements 2, 5, 6, 1, 8, suppose you want to delete the element 5, then it is not that you can write it this way. Okay, it is not like this. If you remove 5 means 0 will be stored there, that is not the correct thing. This is wrong. What should be done actually? Whichever element you want to delete, okay, after that all the elements should be shifted ahead. For example, 2, then 5, then 6, then 1, and then 8. And you want to remove 5. Okay, so this will be the final array after deletion. So can you compare and tell me, has the size reduced or is it the same?
Reduced.
Yeah, so even this size of your array should be reduced. So if n is your size, it will become n minus 1. Okay, n minus 1 elements are there. So index will go from where to where? Can you tell me?
0 to 3.
Yeah, so 0 to n minus 2 you can say. So it will be 0. Yeah, okay. So for example, let me write here 0 to n. Suppose you have n elements and index is from, if it is n, it is from 0 to n minus 1. But now we have reduced the size of your array by 1. Okay, so there are how many elements? N minus 1 elements. And so index will go from 0 to. Now what is the value of n here? It is n minus 1. So it will be, this is your n, suppose, 1 less than this, that is n minus 2 it will become. That is n minus 1. Okay, n minus 1 minus 1. Do you agree with me?
Yes.
Yeah, so it is n minus 2. So this way you can understand this. So to delete an element, see the program. First I'm printing the array. Okay, this is to print the array. Then I'm telling the user enter the position or location of deletion. Means suppose the user says I want to delete the element at position 2. Now index and position, there is a relationship between that. If you are saying position is equal to index plus 1. Okay, this is the formula. Means suppose I say position 2, then I mean to say the element 4. Okay, position means you have to start from 1, first position, second position, third, fourth, fifth, sixth. So here the n is equal to 6 and there are 6 positions, but you can have index from 0 to 5. So suppose index, the element at element 4 has the index 1. So I can substitute here. Index is 1, so position is always 1 greater. So it is position 2. Okay, naturally. If this is position 1, it is index 0. This is position 2, it is index 1. Okay, so there is a difference between position and index. So I'm telling the user enter the position or location of deletion. Suppose he enters 2, then I'm targeting element 4. So element 4 should go off from the array. So how I can do it? I have to again use a loop. Why loop? Because the number of elements after 4 have to be shifted to the left by 1 place. Have you understood this? Have you understood?
Yes.
Yes.
Okay, if you're not understanding, tell me. I can explain again. Now, so your loop will go from location minus 1. Okay, now loop has to always be in terms of index value. Okay, so if I'm saying location minus 1, location, suppose consider users entered 2. So 2 minus 1 is 1. Okay, and in for loop all index values are considered. So is 1 the index of 4? Yes. 2 is at 0, 4 is at 1. So 4 ka index is 1, that is correct. So it is location minus 1. Okay, so this is I is equal to 1 initially. Then I can go up to less than n. N is what? Total number of elements. 1, 2, 3, 4, 5, 6. So I can go up to less than equal to 5, you can say, or less than 6. Okay, both are same. And I plus plus. So what will happen for these index values that was defined in the for loop? So let me dry run it again. So first is, what is the index value of first element which is valid in this for loop? You have to start from 1. Okay, location minus 1. So index is starting from 1. So a of 1 is equal to, see this statement, a of 1 is equal to a of I plus 1. So I value is 1 plus 1. So what is happening? This is not your mathematics in which left hand side is equal to right hand side. Okay, this is whatever is to the right will get stored in the left. Okay, so a of 1 will be equal to the value at a of 2. 1 plus 1 is 2. A of 2 is what? This is a of 0. This is a of 1. A of 2 is 5. So a of 1 is equal to 5. Okay, that means a of 1 was 4, that has become 5. Now, next what will happen? let me just write the array over here. Next iteration, I value is incremented by 1. So a of 2 is equal to a of what? Can you tell me? See here, a of 1, then it becomes a of 2. So a of 2 will become a of what? Are you
5.
understanding? You have to tell me the index. What I must write? A of what?
3.
Yeah, 3. It should be 3. Okay. It is in, see here what I've written in my loop. I is equal to I plus 1. So if I is 2, I plus 1 is 3. So a of 2 becomes the value of a of 3. So for your simplicity, I'll write the index value also here 0, 1, 2, 3, 4, 5. Okay, these are the index values. Okay, so a of 3 is what? This one, 6. So now I'll write the updated array on top. So whatever updation I've done till now, what? This is as it is. A of 1 is changed to 5. Then a of 2 has changed to 6. Okay, so what has happened? This 5, 6, which was in my original array, has shifted towards the left by 1. Okay, that means 4 has gone. Now next iteration, tell me what I have to write. A of what?
3.
Yeah, a of 3 is equal to, yeah, correct. A of what? Right hand side, a
4.
of what? Yeah. So a of 4 is nothing but 8. So 8. And that is the value of a of 3. Okay, so one by one, 5, 6, 8, 9 will come towards the left. Okay, so finally you'll get 9 over here. Now array size initially was 6. Okay, but that has become what? 5. Updated array size is a of 5. Now I can call it new also. So we have to reduce the size of our array also by 1. So what we have to do? N value is not changed till now. We have to decrement it by 1. Okay. So there were n elements. Now there are n minus 1 elements. If there are n minus 1 elements, what are the acceptable values of index? 0 to what?
N minus 2.
Yes, tell me. There are n minus 1 elements. So index is from 0 to what?
N minus 2.
N minus 2. Are you understanding? Should I repeat? Ruchi Patil, are you understanding?
Yes, understood.
Or should I repeat? Am I audible to you?
Yes, repeat one more time,
Yes.
please.
Anyone else can also reply. Are you understanding? Am I audible? Man?
Hello.
Yes.
Yes, yes.
Network issue was there.
Okay, so should I repeat or have you understood?
Understood.
Okay, has everyone understood?
Yeah.
Yes.
Yes.
Okay. So
Yes.
reply, okay, because I don't know whether you're understanding or not. So how can I move ahead? Okay, this is all these courses are for you only, not for me. So we have reduced our size also finally. So there are one less elements, okay, lesser by one. So for a change, let me execute on online compiler, okay. So same program I've typed here. Let us run it. So see here, whatever elements are there, I have printed them. Now it is telling me enter the position or location of insertion. Suppose I say 2. Okay, so I should get the elements in my final array 2, 5, 6, 8, 9. When I click enter, it is, this is deletion, right? Okay, this is insertion program. Okay. This is, let me execute here only. So enter the position of deletion. I entered 2. Okay, finally you'll get, other than 4, you'll shift all the elements to the left and you'll get the size 1 lesser than the original. Have you understood or should I repeat?
Understood.
Is there any del function?
Yes, I could not hear you. Can you repeat, Pratik?
Is there any del function like
Oh,
Python?
del function. Yeah. In Python, there is, but in C, C++, you don't have del function. Okay, so Python has different uh, keywords or predefined functionality, which you may not have in arrays. So to handle this like inefficiency, to perform it faster, you must use the different data structure, that is linked list. So one more conclusion you can derive is arrays are suitable for the data elements which are not changing frequently. Okay, if your element list is changing frequently, you should not use arrays for that list. You must use linked list, okay, because their insertion deletion operations are quick. You don't have to shift the elements, you have to just shift some links in linked list. Okay, so for that purpose we have to study linked list, but for now this is the way you must perform it in arrays and um, in arrays in C language. Okay, is it okay, Pratik? Okay, next we can see how to insert an element. Okay, and these programs are usually not performed. Okay, but I'm just showing you for your knowledge how the index you have to vary and all. Okay, so usually people prefer to use linked list. So now how to insert an element. I have initialized my array. I have calculated the size. I am printing the array. Now I am telling the user enter the position of insertion. Suppose the user enters 2. So I'll show you what should happen. Suppose you have the same array, okay? So user's program is telling me enter the position of insertion. Suppose the user enters, so this is my insert at position, insert at 2. Okay, now position is what? I will write it here. 0, 1, 2, 3, 4, 5. And index is from where to where? It is from, okay, these are the index. And your positions are from 1. Okay, position starts from 1 up to n. There are 6 elements, n is 6. 1 to n, so the index will be 1 lesser, that is 0 to n minus 1. Okay, so insert at position 2. So if I want to insert at the position 2, that means the 4 that is over here should be shifted to the right by one side. Do you agree with me?
Yes.
Yeah. Okay.
Yeah.
So 4, yeah. Okay. 4, 5, 6, 8, 9 all should be shifted to the right by one side so that you get an empty space at position 2, and at the position 2 you will be able to insert a new element. Suppose you want to enter -6. Okay, this is the way you have to shift towards the right. In deletion you have to shift towards the left, but in insertion shift towards the right. Okay, it's obvious. If you want to include more elements, size will increase. If you want to reduce the number of elements, size will decrease. Okay, so insert at position 2. So how we can write our for loop, that we will see now. In for loop, I'm starting from n minus 1 and I have to go up to location -1. Now location is always within or lesser than n, isn't it? Your location, either it is equal to the last element, at the last element you want to perform the insertion, or maybe somewhere before, but you cannot insert like after the range. Okay, I mean to say that whatever n minus 1 is there, that is always greater than location minus 1. Okay, in this case, my n is equal to 6 and my location is 2. Okay, so my n is equal to 6 and location is 2. Now n and location can be the same also, means I want to perform insertion at the last position. So if I want to perform insertion at the last position, then this element 9 has to be moved one place right, and then I can insert my new element x over here. Okay, have you understood this?
Yes.
Yes.
Yeah. So now let us see the case that we are considering. That means my location is 2. So I have to create an empty space at position 2. What is the index of position 2? Can you tell me?
1.
1.
Yes, it is 1. Very correct. Yeah. So in my loop, I'm writing, I'm decrementing, means I'm starting from the last element. What is the index of the last element? 5. And 5 is equal to n minus 1. I've told you many times, if there are n elements, last index will be n minus 1. So you have to start from I equal to n minus 1. So I is equal to n minus 1. And let me consider the value now. I is equal to 5. Okay, that is 6 minus 1 is equal to 5. Now at this value, what I'm doing in my loop, I'm saying that a of I plus 1. What is the value of I? 5. 5 plus 1 is equal to a of, what is the value I should write here? A of what? See the loop no here. If I'm writing I plus 1 over here, what is I?
5.
Yeah, 5. So this is I. That is I is equal to, this is 1 that you're adding and I value is 5. This is nothing but I plus 1. Okay, see here, I plus 1. So this is I plus 1. So what is I? 5. So this will become a of 6. 5 plus 1 is 6. And a of 6 will become the value of a of 5. What is a of 5 here? Can you tell me?
9.
Yeah, 9. So the value 9 will be the value of a of 6 from now on. And what is a of 6? We don't have that index. Why? Because we are shifting everything one by one towards the right, isn't it? To increase the positions so that we can insert the element. We are increasing the size so that the elements are moved towards the right, and then we'll get one empty space, and at that empty space we have to insert our element. Okay, so a of 6 is 9. Then I value will be decremented. Okay, so I will become what? I was initially 6 minus 1. So now 6 minus 1 is 5. So 5 minus 1 is 4. And for this value, a of, what is the value of I now?
4.
Yeah, 4 plus 1 is equal to a of what I should write? A of what?
4.
Yeah, yes, a of 4. So this will become a of 5 is equal to, what is the value of a of 4? Can you tell me?
8.
8.
Yeah, 8. Yes, very good. So a of 5 has become 8. So let me write the updated array now. So 2 is as it is till now. Then 4 is as it is, 5 is as it is. We have only changed the value of a of 5 and a of 6. Okay, so a of 5 is towards the end. So this is also same. This is also same. Now a of 5 is equal to 8. So a of 5 is equal to 8 and a of 6 is what? 9. Okay, so you'll have some duplicate elements like this. Now next iteration, what will happen? This 6 which is here will get copied here also. Okay, do you agree with me?
How?
See what we had to, what you said?
How?
Okay, I'll show you one more iteration. See, now I will become what? 3. For this, what will be? A of 3 plus 1 is equal to A of 3. So A of 4 is equal to A of 3. Now current value of A of 3 is 6. Okay, so A of 4 also became 6. What is your A of 4? This is 4, in value is 8. Okay, so A of 4 also became 6. Have you understood now?
Yes.
Yeah. So one by one, the values are getting duplicated. So in next iteration, this 5 will be same, and here also you'll get 5. Next iteration, what will happen? 4 also will get come here and get copied. Okay, so 4 also will come here. Now what will happen? When should I terminate? When I is equal to location minus 1. What is the value of location minus 1? Location is 2. So location minus 1 is 1. Okay, I'll write that also. This is location. So location minus 1 is equal to 2 minus 1 is equal to 1. So when my index value, that is I, is 1, that is at this position, I must stop. Okay, I must stop. So this is my value which is not wanted. Why not wanted? Because at this location, at location minus 1, which is equal to 1, means position 2. Okay, location minus 1 is equal to 1, that is index 1. But what is the position 2? I have told the program at position 2 I want to insert. Means at index 1, I have reached that stage now. So there I want to insert. So in my updated array, this value 4 should get replaced with whatever I want to insert, suppose x. So in this way, whichever duplicate value was there, that has been eliminated. And whatever you want to insert, that you'll insert. Now how? Outside your for loop, you can increase your size of n. Why? Because elements have shifted to the right, you have to increase by 1. And at location minus 1, what is location minus 1? 1. What is 1? Index here. At that index, you want to insert. So at that index, that is location minus 1, you want to store whichever element you want to store. That is item if you want to store, then this will become item. Have you understood this program?
Yes.
Yes.
Yeah.
Yes.
Okay. So you can practice this on your own also. I know it's a little difficult for the first time because you're dealing with arrays for the first time, but keep practicing this. Okay. You have to be like, suppose anyone says you there are n, tells you if there are n elements, immediately you should understand there are n minus 1 till there your index goes. Okay. These things are same for all the arrays. It does not change for any array. Okay. So these things you have to keep in mind. And this is how you can manipulate the data. Okay, based on index only we have to do everything. Okay, there is no other option. So for a change, as I said, you have to, I'm executing on the online compiler. So same program, I tell the program that I want to, or the programmer, I want to insert at position 2. Okay, then when I click enter, it will ask me enter the element to be inserted. Okay, this is a simple scanf statement. So if I enter the element 6, okay, then I click enter. So see here, position 2 is what? This position. So 4, 5, 6, 8, 9 have to be shifted to the right. And at this position, my element 6 is coming. So all these other elements are shifted towards the right. Have you understood this program?
Yes.
Yeah. Okay, very good. So I think we should stop here, otherwise it will become too much. So quickly put your attendance in the chat box and you can ask me any doubts if you want. If you have any doubts regarding that spreadsheet, I'll send you the link now. Anything about that or any other doubts or anything else if you want to know. Okay, so if you don't have any doubt, you can leave this meeting. Thank you.
Thank you.
Welcome.
Thank you, Dada.
Welcome.
Thank you, bhai.
Welcome. And since this is important concept, I'll also send you the recording of this video so you can hear it again and again.
And via this we have started with data structures.
Yes.
Okay, so this is the first topic of data structure.
Yeah. And these data structures can be implemented using any language. But since we are studying C programming, I'm using C language.
Okay.
Yeah.
Thank you, Vaya. Bye.
Yeah. Welcome. Bye bye.
Bye.
Bye bye.
Thank you.
Welcome.
Bye.
Bye bye.